This video is an explanation of one of our enrichment problems, and this problem says Jemima's age has the same digits as her grandmother but reversed. So that just means if the age of one person is 27, the other person would be those digits reversed, so it would be 72. It says the difference between their ages is 5/11ths of their sum. How old are they? I'm going to use an algebraic expression to solve this, and I'm going to call Jemima's age J, and I'm going to call the grandmother's age G. So the difference between their ages means if we take the grandmother, who's going to be older, and we subtract Jemima, that's the difference between their ages, that is equal to 5/11ths of, which means multiplying, 5/11ths of their sum, the grandmother's age plus Jemima's age. Now I just need to solve this equation, and I'm going to move this to another page so I have some more room. So now to solve this, we need to distribute the 5/11ths to both terms in parentheses. On the left-hand side, we have the difference in their ages, G minus J, is equal to, on the right-hand side, 5/11ths times G, which I can just put as 5/11ths G, plus 5/11ths times J, or 5/11ths J. Now I need to solve for one of these variables. And I'm thinking I'm going to add J to both sides. So that gives me G minus J plus J. That just gives me G on the left-hand side. These cancel out. On the right-hand side, we have 5/11ths G plus 1J plus 5/11ths J, which is 1 and 5/11ths J. I can now take 5/11ths G away from both sides. And on the left-hand side, that gives me 6/11ths G. On the right-hand side, the G's have all canceled out. So all I have left is 1 and 5/11ths J. I'm going to convert that to an improper fraction. So as an improper fraction, that would be 16/11ths J is equal to 6/11ths G. And the last thing I'm going to do is I'm going to divide both sides by 6/11ths. On the left-hand side, the 6/11ths will cancel out. So we'll just be left with G. And on the right-hand side, we're going to have to do some work because we have 16/11ths divided by 6/11ths. In other words, 16/11ths times the reciprocal of 6/11ths, which would be 11/6. Cross simplification, and this would be an 8 and a 3. We get 8/3. So G is equal to 8/3 J. So what this means is that grandma's age is 8/3 of Jemima's age. Now, in order to solve this, we're going to have to start thinking about what could Jemima's age be. And no matter what Jemima's age is, we're going to want to multiply it by 8/3. And we're going to want the denominator of this fraction to cancel out. So whatever is Jemima's age is needs to be a multiple of 3 so that we can divide it by 3 and then multiply it by 8. So we only want multiples of 3. And this is what I mean. If Jemima's age was 24 over 1, we could then cancel out the 3, and then grandma's age would have to be 64. Of course, that doesn't work because their digits have to be reversed each other, and 24 and 64 aren't reversed. If we had chosen a different age for Jemima, like 20, for example, the 3 wouldn't evenly cancel out, so that would leave grandma's age as a decimal or as a fraction. And this is where we can now just try some multiples of 3. So for example, if we said Jemima was 15, the grandma would be 40, and 15 and 40 are not reversed digits. So let's go with a larger number. Let's say Jemima is a multiple of 3. Let's do 33. That would make the grandma be 88. And 33 and 88 are not reverses of each other. So it looks like we're getting a little bit farther away. It looks like we're going to be somewhere between 15 and 33. If we chose a number that is much larger than 33, the grandma would have to be in her hundreds. So that's not going to make too much sense. So I'm going to pick something that's somewhere between 15 and 33. Let's say 21. That would give us 56, 21 and 56. That's not going to work, so let's try 27. And that gives us 72 for the grandma's age, and Jemima's age is 27. Those are reverses. We can confirm our answer now by plugging our solution into our original problem. So the difference in their ages, 72 minus 27, should be equal to 5/11ths times the sum of their ages, 72 plus 27. The difference in their ages is 45. The sum of their ages is 99. So 45 should be equal to 5/11ths of 99. We can work that out. 5/11ths times 99 over 1. Some cross simplification. And we get 45 is equal to 45.